Okay, let's get started today. So today we are going to be finishing up with normalization, and I realize that it may have been a bit confusing for y'all on Tuesday because there's a lot of moving parts, and hopefully as we get to the few remaining parts today, it will all come together. And we're also going to be going over a case study, so hopefully that will also help to bring the pieces together. Wanted to remind you that I extended the deadline for the quiz from Tuesday till tomorrow at 12:30 because I know there might have been some confusion with normalization, so you have an extra day for that quiz. The quiz for today is still on. It's still due next Tuesday at the normal time. So what I want to do is do a quick review of the normalization concepts that we've seen so far, then finish the algorithm that we started, because normalization is really an algorithm for decomposing relations. And once we've finished with the algorithm, then go through the case study for today. So the review going to be rather rapid and just a quick review through the slides that we had from last time. So normalization is a bottom-up design technique, and it's used to, as I said, decompose relations based on logical groupings of attributes. And those logical groupings are defined by something we call functional dependencies. And we're trying to reduce redundancy and inconsistency in our database with the normalization technique. You can use both ER diagrams and normalization when designing your database. They're not mutually exclusive. I tend to go back and forth between the two, and I use one to check the other. So I think using one to check the other is always a good idea. And we went and looked at the kinds of anomalies that we can have in a relation. There were three types. There's insert, I'm going to jump ahead. There's insert, delete, and modification anomalies. So insert refers to the inability to insert an entity into our database. And the reason would be because a relation is trying to represent information about two or more entities, and the primary key is on the other entity, entity A, and therefore we can't insert entity B without some instance of entity A. So that's an insert anomaly where we cannot insert an entity into a relation. A delete anomaly is what? Mm-hmm. That's right. So a delete anomaly is where you delete all the info. So if you have, again, this comes up when a relation is basically representing instances of both entities A and B. And when you delete all instances of A related to some instance of B, you lose all the information related to that instance of B. So that's a delete anomaly, that we lose all the information associated with that B instance if we delete all of its A-related records. And then modification anomalies come about because we have redundant storage of attributes. An attribute is stored, its value is stored in more than one place, and if we change it in one place, we have to update it in another place. We don't consider primary keys and foreign keys to be redundant. So they may be repeated. There's no way around that. But if it's not a foreign key and it's not a primary key, then we do our best to not store an attribute's value multiple times. We try to store it just once. And the point of normalization is to get our relations into a state such that none of these three anomalies exist. Okay, and when we do normalization, when we do our decomposition, we want to make sure that when we break a relation into two or more relations, that we can join those relations and recreate the original relation. So we lose no information, hence the word lossless join. And the second property is that if there is some kind of dependency or constraint enforced in the original relation, then when we decompose that relation into multiple subrelations, that dependency or that constraint is preserved in at least one of the subrelations, that constraint still exists. It's not lost. So then we said that normalization involves grouping related attributes together. And intuitively, what that means is grouping the attributes associated with an entity together and storing each entity in its own relation, something the entity relationship modeling system also attempts to do, but it does it from a top-down perspective. With normalization, the way that we group related attributes is by taking advantage of something called functional dependencies. And if you remember, I said that a functional dependency is a relationship among attributes, whereas in ER modeling, we're talking about relationships among entities. Very good. So we have these functional dependencies, which in the normalization jargon, we're going to write it as A arrow B. It means that attributes A, each unique combination of attributes in A have a unique value in B. And we say that the left-hand side A, what do we call that? A determinant. Very good. So essentially, what's going to, well, let's keep going for a moment. So we want our functional dependencies to be the minimum set A required to uniquely determine an attribute or set of attributes B. We don't want A to have superfluous attributes. So if it is the minimum number of attributes necessary to maintain the functional dependency, we call it a full functional dependency. If it has an extraneous attribute, we call it a partial dependency. So this is an example of a partial dependency. We say staff number and staff name, they determine the branch number. However, what's superfluous here? The employee name. It is also the case that staff number by itself uniquely determines the branch number, and therefore staff name is superfluous. Therefore, while this is a functional dependency, we call it a partial functional dependency because it doesn't have the minimal number of attributes. Basically, our decomposition is seeking to take these full functional dependencies, and as a general rule, each full functional dependency is going to end up in its own relation. It's a generalization, but as a general rule, so I'll write that here, a general rule, okay, is that each full functional dependency, or the attributes, I'll say the attributes in each full functional dependency end up in their own relation. Now there's one exception, and that exception is if a full functional dependency denotes a candidate key, and that candidate key is not selected as a primary key. So if, I'm going to abbreviate as FD, if the functional dependency represents, if the left hand, if the determinant of the FD is a candidate key, and is not selected as the primary key, it might not end up in its own relation. So that's the one exception. But otherwise, in general, each functional dependency, the attributes in that functional dependency will end up in their own relation. Okay, so a second type of dependency is a transitive dependency, and it's the kind you're used to. If A determines B and B determines C, then A determines C. And in the staff-branch relationship that we had the staff number determined the branch number, and the branch number determined the branch address. So a transitive dependency is that staff number determines branch address. And we don't explicitly represent transitive dependencies when we list our functional dependencies, we don't list transitive dependencies. We consider them redundant because they're implied. We also don't typically, even though the branch address right here, the branch address is dependent on staff number, we don't put it over here because really the branch address is dependent on branch number. Okay, so that again is in effect saying we don't explicitly represent transitive dependencies. Okay. So then the process of normalization is a series of steps where we first need to identify our functional dependency. Well, actually, we first identify something we call the universal relation. Basically, we put all of our attributes into one huge relation. Then the second step, we identified the functional dependencies. The third step was to identify a primary key. And the fourth step is to start converting these relations into the different normal forms. And there are multiple normal forms, and in this course we'll consider only 4. Unnormalized normal form, first normal form, second normal form, and third normal form. So the unnormalized form is where you simply you don't have one value per cell. You have either multi-valued attributes in your cells or you have repeating groups. And to eliminate that, you either in the case of multi-valued attributes move them off into their own relation, or with repeating groups such as the case where you have a client that's rented multiple properties, you simply draw lines between the different properties in that case. So it's pretty easy to go from unnormalized form to first normalized form. First normal form simply says every cell has one value. Then this is where we kind of end it, was with second normal form. So this is where we kind of start today with new material. So second normal form is where we have removed so-called partial dependencies. So we say that every non-primary key attribute must be fully functionally dependent on the primary key. Okay? And the operational definition of that is we remove all partial dependencies on the primary key. So as an example, we're going to do a slightly different example than the staff branch relation. I'll tell you why. Well, I'll tell you just right now, if you have a primary key that is a single attribute, then it is already in second normal form. Okay, and you'll see as we go along why that's the case. So instead of the staff branch relation, we're going to use a different relation, which is a client rental relation. So we're keeping all information about leases. Okay, this could also be called a leasing relation. Maybe remember we can take our relations from different forms. This might come from a lease form. So these all the attributes you see up here, the client number, the property number, client name, property address, the starting and finishing dates for the rent, when they rent from us, the rent, the owner number, and the owner name, those are all fields you might find on a lease. So you might very well call this a leasing relation. But it's not in second normal form, and we will find that out by coming up with our functional dependencies. So here, anything with not an arrow on it would be a part of the determinant on the left side, and anything with an arrow would be on the right side of the arrow. So here, we're making the assumption that the client number and the property uniquely determine the starting date for the rent and the finishing date. So we're assuming a client doesn't rent two properties from us simultaneously, and we're assuming also that one person is on the lease. There are not multiple people on the lease. And you'll notice that, in fact, the client number and property number also determine all of these other attributes. So the client number determines the client name. The property number right here determines the property address, the rent, and the owner number. It actually, based on what I just said, I shouldn't have an arrow here for owner name. And that reason is why. Why shouldn't I have an arrow here for owner name? Because it's transitive. It's actually dependent on the owner number. So I actually should not have, and I'll try to get rid of that, this really shouldn't be here because we don't explicitly represent the transitive dependencies. Okay, so we can say that the client number and the property number are the primary key because in addition to determining these two attributes, there are two sub-attributes, or client number and property number, determine all the remaining attributes. Okay, in some sense. I guess you could say the property number determines the owner number, which in turn determines the owner name. But together, client number and property number uniquely determine all the attributes, and therefore they can be a primary key. Yes?
So we're having to assume that the same client never rents the same property at a different time.
No. So we're allowed to assume that they rented that property at two different times. Wait, is that? Yes. No, you're right. We're assuming they can't, yeah. We're assuming they can't rent the same property twice.
So that wouldn't work.
So, yep, here's that assumption. I know it's hard to read, but
Okay.
it was a client will not rent the same property on 2 different occasions. If we allow for this possibility, then we need to add rent start to the primary key. Yep, very good. And we're also assuming a client will not simultaneously rent 2 different properties. So thank you. Yep, I had stated one of those 2 assumptions, but not the second one. Okay. Other questions? Okay. So that's, once you've come up with the primary key, you can't stop. There may be other functional dependencies that are candidate keys. And here's are a couple other functional dependencies that are in there. So the client number, and based on what we said, the assumption actually you just mentioned, we're assuming that the client and the rent start uniquely determines everything else. And in this case, you'll notice that we have a lot of arrows. And you might say, well, why is that? The reason is, in this case, the client number it determines the, well, actually, based on what I just said with transitivity, I probably should only have client number determining property number here. And I should allow the property address, the rent finish, the rent, the owner number, and owner name to be determined by what? Property number. So again, I will fix this. Really, based on what I'm saying, where I shouldn't be showing transitivity, I should say that the client number and the rent start determines the property number, but these right here are all attributes that transitively depend on either the property number or the property name, and therefore they shouldn't be there. Yes, thank you. I do need, very good. I do need rent finish. So rent finish does depend fully on the client number and the rent start. Okay, and then the second candidate key is client number, I'm sorry, property number and rent start. Because we're assuming that only one person is on the lease, and therefore the property number and the rent start also uniquely determine the candidate, the client number, and the rent finish. And this will typically happen when you have multiple relation or entities in the same relation. You will have multiple candidate keys where each of the entities can be one of the candidate keys. So here, this first candidate key was solely on client, the second one was solely on property, and then we had the primary key that we chose, which was dependent on both. So when you're going through the homework, another general rule that you want to be aware of is that a general rule, again, it's not always holding for all time, but in general, each entity by itself, well, each entity will be part of a candidate key. Okay, so here, client number was part of one, property number was part of one, and actually then the 2 together were part of one. But it's not enough, as you saw here, even though that one you say, oh, they're both part of the same candidate key. True. Will typically be part of a candidate key involving only that entity. Now, that's not always the case, but it often is the case. So I shouldn't say general rule, but something to check. So maybe rather than something to check. It's not always the case. Let's say that let's see. I'm actually having trouble coming up with good examples. So actually, this is a pretty good general rule. Okay, each example I actually came up with quickly in my head. Didn't. So in general, you should check to see if each entity will be part of a candidate key involving only that entity. Yes.
Would that only apply to strong entities?
Yes, very good. That would only apply to strong entities. Weak entities, that's not going to be the case. So that only applies to strong entities. Okay. So we have this. Now, we say that these two dependencies right here are partial dependencies in this case because property address, rent, owner number, and owner name, it's true that they depend on both client number and property number, but they actually depend only on property number. So if we were to try to say that the property address depends on client number, and property number, well, that's true. That's a partial dependency because, in fact, property address depends only on property number by itself. Client number is superfluous. So we want to get rid of this so-called partial dependency of all attributes on property number alone. And similarly, we want to get rid of this so-called partial dependency of client name on client number. Because remember when we said back here, we said a relation is in, a second normal form relation is one where it's in first normal form and every non-primary key attribute is fully functionally dependent on the primary key. Well, here, property address is not fully functionally dependent on the primary key. It's only dependent on property number. So we have to get rid of these partial dependencies. Does that make sense? This always trips up students. This is a key one. Okay. I'm sure once that we get out of my professor clarification bubble and you get to your homework assignment, it will pop. But feel free to ask me questions at that point. Okay. So what we have to do is we're going to remove the attributes on the right-hand side of the property numbers functional dependency, and we're going to move them to their own relation. The property number is going to both move to the new relation as a primary key and is going to stay in the original relation. So the determinant stays in the original relation, and the determinant and the attributes, well, the attributes on the right, okay, so let's write this down. So a rule for this. So if we have A goes to B, we form a new relation with both attributes from A and B. So we have one new relation which involves all the attributes of A and B. And what do you think A represents in this new relation? I think I heard it.
The determinant?
The determinant is good, and primary key. So A becomes the primary key in this new relation. Now in the old relation, so we'll say original relation, A remains, but B is all B attributes, so all B attributes are removed from the original relation. But A remains, and even if A is part of the primary key, what in effect is A now in the original relation? It may be part of the primary key, but it will also be a foreign key. Very good. In the original relation, A becomes a foreign key, and A is what allows us to have a lossless join. So A, we can join, if we join R with the original relation, we can join on the attributes in A, and now we get back the complete original relation. So A is the key. That's why we keep A in the original relation. It becomes the foreign key. It's how we obtain the lossless join property. Now, when we did this, we also preserved the dependency. The dependency for A determines B went where? New relation. It went into R. So we both have the lossless join and dependency preserving in this first normal form to second normal form transformation. And we are reducing our, now by doing it, we eliminate the insert and delete anomalies on A. Now we can insert on A without remember, A was part of some bigger primary key. So it might have been A and C were the primary keys. Okay? It's a good chance that both A and C are entities. And before, we couldn't insert A without having an instance of C. By moving A off into its own relation, we resolve that insert and delete anomaly that we had before. We also are going to probably get rid of multiple repetitions of B. So we're probably also getting rid of modification anomalies. Okay. Now, why did they choose this as the first step? I can't tell you. I don't have that theoretical knowledge. I just know that they chose this as the first step to go from first normal form to second normal form. This is essentially one way of breaking apart two entities. Okay, you can think of this as separating entities into their own relations, because typically what's happening is the primary key has two attributes from two entities in it. Okay, so we are going to take property number and all of its corresponding attributes, and we're going to move it into a separate relation. And we're going to do the same thing with client number, because client number was also a partial dependency. It was part of the primary key, and it uniquely determined the client name. So those two attributes also go off to their own new relation. And we're now left with this so-called rental relation, which still has the client number and property number. So it still has the two determinants that we moved, but we've deleted all of the attributes on the right-hand side of those two dependencies. And all we're left with are rent start and rent finish, and they are fully functionally dependent on the client number and the property number. They depend on both because the property can be rented multiple times. So by itself, the property number does not uniquely determine the start of the rent and the finishing dates. Similarly, we're allowing the client to rent multiple properties from us, so by itself, the client can't uniquely determine the starting rental date and the finishing rental date. So we need both. So rent start and rent finish are fully functionally dependent on that key. Okay? So that's second normal form. Now, we're not done because we still have a bit of an issue. It's right here. This owner number, this owner name rather, may get repeated multiple times. And the issue is there's a transitive dependency here. We have owner number determines owner name. So we now introduce third normal form to get rid of transitive dependencies. So the first one to second normal form eliminated partial dependencies on the primary key. The second one we're going to do is going to eliminate transitive dependencies. And again, we are going to be getting some splitting of entities into their own relations here. In this case, the owner is going to be split off into their own relation. So the transitive dependency is owner number determines owner name. So again, same thing, we're going to move the right-hand side, which is owner name, off into its own relation. Owner number will be kept in the original property for rent relation and will also appear in the new owner relation. It will be the join attribute. So again, when we do these decompositions, the rule is the determinant appears in both the original relation and the decomposed or new relation. The right-hand attributes are deleted from the original relation and they are transferred to the new relation. Okay, and again, we have eliminated an insert anomaly where we couldn't insert an owner without having a property. And we eliminated the corresponding delete anomaly, which is if we deleted all the properties associated with an owner, it would delete that owner. So we've deleted both of those anomalies. Plus, we've eliminated the modification anomaly that the owner name might be there multiple times. Okay, so this is, you've actually seen now the complete normalization process. So we started with a single huge unnormalized relation. Then we identified functional dependencies. Then we identified a primary key. And then fourth, we removed partial dependencies to get second normal form. And then fifth, we removed transitive dependencies to get third normal form. Third normal form is pretty good. There can still be some anomalies in it, but it works out pretty well. So are there questions about this? Now go ahead.
I guess what I'm wondering is it seems like converting from first normal form to second and second to third is almost identical, like very, very similar. Is it super important that we understand which conversion we're doing as long as it's correct?
Yes, it's really important to know when something is in second normal form and when something is in third normal form. Okay, this is more theoretical knowledge. In general, you want to end up in third normal form.
Right.
But I do want you to know for the purposes of this what it means to be in second normal form and what it means to be in third normal form. I know what you're saying, but it is an important distinction. Some dependencies are what we call partial dependencies, and some dependencies are what we call transitive dependencies. So you need to know which is which. Okay? Yes?
You say it's important to make sure we're in the third normal form. Doesn't it really just matter if we need to be in the final normal form, depending on how many entities we've drawn into the relation?
So The bottom right. So in the real world, what you care about is the end, which is that you've just separated all of the entities into their own relation. Okay. I guess my best thing is, as you are for the most part, computer science majors, you are expected to know the theoretical basis. So you should know the algorithm for doing it. Okay. It's kind of like in 302, you could say, well, as long as the matrix or the graph, I found the shortest path, that's all that's important, right? But we want you to be able to show us the steps that you use to get there. Okay. And to kind of show you that second normal form and third normal form can differ depending on what you choose to be the primary key. So let's say that it wasn't a foregone conclusion that client number and property number had to be the primary key. I could have chosen either of these other two candidate keys to be the primary key. Had I done that, let's say I chose client number and rent start to be the primary key. If I had done that, then this relation would immediately be in second normal form. The reason it would be in second normal form, can someone tell me? I hinted at it earlier. There can't be any partial dependency. The only time I can have partial dependencies is if there are multiple attributes in the determinant. If there's only one attribute in the determinant, there can be no partial dependencies. By definition, it is minimal, and everything is fully functionally dependent on it. So in that case, everything else would have become transitive dependency. So in that case, the functional dependency of property number determining property address, rent, owner number, and owner number, that would have been a transitive dependency. And owner number determining owner name would have been a transitive dependency. So they would have gotten moved out when I went from second normal form to third normal form. So in the end, I would have ended up with the same set of 4 relations. I'm not sure if I have them all here. But in the end, I would have ended up with let me type it out. I would have ended up with the relation client number, let's see. Let's do this more slowly, make sure I have done this right. So I would start, and in second normal form, I would still have property for rent, and it would have everything in it. Client number, actually that's not true. Let me take that back. Because I was wrong. How was I wrong? Why is it really not in second normal form if I choose client number and rent start to be the... Very good. So I wasn't right. There were 2. I was thinking there was only 1 attribute in that key, but there was 2, client number and rent start. So in fact, this wasn't in second normal form because I had this relation client number determines client name. So to transfer to second normal form, I would have used client number determines client name and removed that. So in fact, to get to second normal form, I would have used client number determines client name, and that would have given me 2 new relations. One would have been client with client number and client name. The other would have been still, say, property for rent with everything else. It still would have been client number, property number, rent start, rent finish. Would have had property address, property owner, all the other stuff. And then to go to, so this would have been to go to second normal form. Would have been this one. And then to go to third normal form, I would have used the relations or the functional dependencies of property number determines property address and rent and what else? Thank you, owner number. And I would have used then owner number determines owner name. And I would have used those two to get me from second normal form to third normal form. So I would have had the same outcome in the end. I would have had the same four relations, but the second normal form would be different. So the choice of your primary key does matter. Yes.
In general, is it always going to be the same outcome if you go through all the steps?
Yes. In general, it's going to be the same outcome in third normal form.
Right.
To third normal form, not necessarily beyond that. The third normal form, yes, it will be the same outcome. Just two different, all roads will lead to Rome, but they will be different roads.
Right.
Now, what I was saying, however, one statement I did make was true. So going way, way back to the staff-branch relation, that really is the case where if I choose the staff number to be the primary key, and it's the only attribute, then by definition it's in second normal form. So if my primary key has only a single attribute, then by definition it's in second normal form. There can be no partial dependencies in that case. Okay, that's a tautology. Final thing, and I'm not going to dwell on it, but you should know that there is a stronger version of normal forms than we've talked about. And I'm not going to worry about it too much, but we did all of our decomposition using primary keys. A stronger form would be to do the decomposition using any candidate key, meaning that when we were done with second normal form, then it's only in second normal form if every non-primary key attribute is fully functionally dependent on any candidate key. So not just on the primary key, but on any candidate key. And in fact, what I just did shows you the distinction. I'm not going to hold you to knowing this, but when I was done, if I chose that client number and the rent start as my primary key, when I was done with the extracting the client number, based on primary key alone, this was in second normal form. This property for rent was in second normal form. But based on the candidate key criterion, it's not in second normal form. And the reason is that another potential candidate key is client number and property number. And based on that, property address, property owner are not fully functionally dependent on that candidate key. So under that stricter definition, which I will not be holding you to, this would not, while this is second normal form in primary key definition of normal form, it is not in second normal form under this stronger definition that the non-primary key attributes must be fully functional on any candidate key. If this were a graduate course, I would expect you to know it. Actually, the graduate students, I still won't hold you to it, but this is more of an advanced concept, and that's why I'm not holding you to it. I just want you to know that there is a stronger form than what we're using, where you'd have to eliminate dependencies not only on the primary key, but also on candidate keys. Okay, and then not only, it wouldn't really matter anymore. Not only would third normal forms basically be the same, but all your second normal forms would be the same. Okay, but we're not at that point. So questions. Don't worry too much about this last slide. I won't be testing you on it. Just want you to be aware of it. Okay, so we have a case study today, and it's one that you are at this point quite familiar with because it is the hotel relation before we decompose it, or the hotel database before we decompose it. So in a real system, so when you were doing your homework assignments for homework 1 and homework 2, you were given a set of relations for the hotel database. But how did we come up with those relations? I mean, yeah, we gave them to you, but in the real world, how might we have come to those relations? And in the real world, what we probably have is that the hotel guest fills out a web form or calls up the hotel and books a room, and we record all the information from the guest into one big row. So it's a big mess. It's basically a reservation that you see there that has all the information about the hotel, the guest, and the room that they're staying in. And now we need to decompose this thing. What do we call this big, enormous relation again? The universal relation. So now we need to decompose it. And the first thing we need to do is we need to know what assumptions we can make about the data. So we're assuming that a hotel number uniquely determines the zip code for that hotel and its name. Okay, that's a bit iffy because we know how hotels love to shove lots of hotels into the same zip code. But to make it life easy, we'll assume that. We'll assume that a zip code uniquely identifies a city. Again, we know that's not true. Knoxville has multiple zip codes, but we will assume it to make our lives a little, well, actually to just make the problem a little easier. We will assume that a guest number uniquely determines a guest name and the guest zip code. We will assume that a room number and a hotel number, so a room at a hotel, that determines its room type and its price. That seems pretty reasonable. A guest may not have overlapping reservations. You probably hurt your head over this one on the homework assignment. And a room may not be double booked, something you probably also hurt your head over. Okay, so those are the assumptions that we can make about the data. So from that, we've already, remember, what is our normalization process? Well, it is create the universal relation. We just did that. We're given our assumptions about the data. So if we want to normalize these, we have to come up with a set of functional dependencies, which we can do based on the assumptions we make about the data. So a hotel number uniquely identifies a hotel's name and zip code. Sounds like a functional dependency. Okay, I know it says give an example of anomalies. I will get to that in a moment. But let's first concentrate on what are the functional dependencies. So A gives us hotel number, determines hotel name, and zip. I'm just going to write it as zip, but it's really zip code. Then we have zip code uniquely determines city. And B, it has zip code, which I'll just abbreviate as zip, uniquely determines city. C says a guest number uniquely determines a guest name and a zip code. So a guest number uniquely determines a guest name and a zip code. D, a room number and a hotel number uniquely determine a room type and price. So this is real nice, right? Each one is actually giving us a functional dependency. Okay, that's price. I know it's hard to read on the right-hand side. That says determines room type and price. Okay. Now E gives us a guest may not have overlapping reservations. So guest number is probably going to be what we're talking about. And they can't have overlapping reservations. So a guest number, and what else do we think we are going to have for E? They can't have an overlapping reservation, but a guest number by itself can't determine the reservation. Pardon? Date from. So a guest number and date from is going to determine what? Can't be overlapping. It's going to determine what? It is going to determine, yes, the hotel number, the room number, whoops. What else?
Day 2.
Date 2, very good. And I can come up with another functional dependency that's very similar to that one, from that same one. I just need to change one attribute in the determinant and one attribute in the right-hand side. What can I swap? Date 2 and date from. So another functional dependency is guest number and date 2. Obviously, this isn't really intuitive, but it is also true. So in fact, E determines 2 functional dependencies, or sets up 2 functional dependencies. I'd expect both on an exam or a homework assignment. Okay, and finally, a room may not be double booked. So it kind of is certainly suggesting that there is a room, but a room number by itself is clearly not unique. What else do we need? A hotel number. Okay, but by itself, those two aren't unique because they can have more than one booking. What will make it unique? Date from. And since they can't be doubly booked, what do they uniquely determine? Guest number and date 2. Very good. And as before, we can come up with a second one, which is room number and hotel number and date 2 will determine guest number and date from. Now, remember, so these are all of our functional dependencies. We're done with A through F, so that we've identified all the functional dependencies. And, well, I'll leave it there for the time being. But hopefully you've written down these functional dependencies. Actually, I'm going to have to get rid of them. So I'm just going to make a quick point here, which is that these two functional dependencies involve the same attributes, and the ones you see here involve the same attributes. So earlier I said each functional dependency will result in its own relation, but clearly these two functional dependencies aren't going to end up with independent relations. They're going to both map to the same relation. It should be clear that probably when we're done that those two functional dependencies will map to the same relation because they involve exactly the same set of attributes. It's just we've varied what is on the left and right hand sides. Okay, but there's a good chance then that each of the functional dependencies you see up there is going to end up with its own relation. And then the question becomes, is it in the second or third normal form version? After we're done with third normal form, there's a good chance that each thing you see up there is going to be its own relation in third normal form. Okay, so while we do have them all up here, we need to identify what is the primary key for this particular reservation. And it turns out there are more than one. Okay, so can someone tell me one possible primary key for a reservation? You can look at the functional dependencies. A couple of the functional dependencies are giving it away. Hotel number by itself is not going to uniquely determine a reservation, but it will be part of one of the primary keys. What else do you need to have in addition to a hotel number to uniquely identify a reservation? Room number, and a date from or a date to. So over here, each of these determinants represents a potential candidate key. There is another candidate key, one that you are more familiar with when you call up the guest number and date. So right here and right here, those are two more candidate keys. Okay. Hotels are generally more used to working with the guest number, and we're typically more familiar with when we're checking in than when we're checking out. Therefore, the best primary key to probably choose would be guest number and date from. So that's what we will use to do our decomposition. So it's very important to know what your primary key is when you do the decomposition because, as you saw earlier, the second normal form will be different depending on the primary key you choose. The third normal form, as we said, all roads lead to Rome, will be the same, but the second normal form will be different. And because this is it's boring, if my primary keys are single attributes, you can be pretty much guaranteed that on homework assignments and midterm exams, primary keys will have multiple attributes. Okay. So if we say that guest number and date 2 is the primary key, what becomes a partial dependency? Which of the functional dependencies we have here? So we will number them now. 1, 2, 3 is zip code, 4, 5, 6, 7, and 8. Which of those functional dependencies is a partial dependency? Number 4, and only number 4, because it's the only one that has a subset of the primary keys in the determinant. All others do not have a subset. Okay, 6 has guest number in it, but it's not a subset of 1. Okay, so only 4 is a partial dependency. So when we go from first normal form to second normal form, the only thing that is going to go with guess that's going to come out is right here with a caveat. The caveat is that you have to also transfer any attributes that are transitively dependent on the right-hand side. I didn't actually make that clear previously. So in this case, what other attributes going to have to come with guest name and zip code?
Guest city.
Guest city. So in fact, when we go to second normal form, we're going to have a new relation, guest, which is going to have guest number, guest name, the zip, and because there's a transitive dependency of city on zip, the city has to come as well. I did not say that earlier. I need to say it now, that when you go to second normal form, if you have A determines B and B determines C, then in second normal form, you will have A, B, and C all in that second normal form relation. The C attributes have to come as well, or some subset of attributes in B determine C. In this case, it was only zip determined the city. Okay, so that all came, and we're left with the original reservation, which still has everything else. So reservation will have guest number, we'll have hotel number, we'll have room number, we'll still have the hotel zip, and we'll still have the city, hotel city. It will still have, let's see, the price, the room type, and the room price. So the only attributes that moved out were the guest city, the guest zip, and the guest name. So this is now in second normal form. Now, to get to third normal form, we go back and look at our dependencies again. First thing to know is not all of the remaining dependencies are transitive dependencies. We have 3 types of dependencies. We have once we've identified the primary key, we can have a partial dependency. We can have a transitive dependency, and we can have what I call candidate key dependencies. Candidate key dependencies aren't used in the normal form conversion. although you probably will use them to check afterwards because they still must be preserved. Dependency preserving means they must be preserved. So, given that, what are the transitive dependencies? Which numbers? Okay, so one is so 6 was the primary key dependency. We've already identified 4 as a partial dependency. Is 1 a transitive dependency or a candidate key dependency? Candidate key. Okay, what about 2? It's a transitive dependency. So a transitive dependency is a non-key. Hotel number is not a key. Okay, what about 3? It's a transitive dependency. What about 5? 5's a little tougher. It is a transitive dependency. It's not a candidate key. 7 and 8, because I'm a little short on time, are candidate key dependencies. So I'm going to use 2, 3, and 5. 2, 3, and 5 to do my decomposition to third normal form. So to get to third normal form, my dependencies were hotel number determines hotel name and hotel zip. And I had zip determines city. And I had room number and hotel number determining the room type and the price. Okay, so when I go to third normal form, I'm going to have a new one that I'll call hotel, which has hotel number, hotel number, hotel name, and hotel zip. I'll have one that is zip, and it has a zip code and a city. And the last one is room. So it has room number, hotel number, room type, and price, which is exactly, except for the zip code one, what you had for the hotel relations in your homework. So that's how you actually got to it. And actually reservation, which now becomes the booking, all it's left with is you're looking back up here, it's still going to have the guest number, and it's still going to have the hotel number, and it's still going to have the room number, because those were all in the determinants. And it's still going to have the date from and date to. Okay, and the final thing is you need to make sure that when you're done, that all your dependencies were preserved. There were 3 candidate key dependencies that were left, 1, 7, and 8. And if you look, they all involve the same 5 attributes: guest number, date, hotel, and room. All of them involve the same 5 attributes, and voila, booking has those 5 attributes in them. So the booking still is maintaining those 3 dependencies that I had. So all of my functional dependencies are still being preserved in my final normal form. Okay? So I'm going to post the answer to this. You will see in the answer the insert, update, and delete anomalies. I'm not going to go over them. I think they're pretty clear. If you have a question, however, about them, do not hesitate to post the question to Piazza. And on next week, we're going to get into physical design, which is the final part of our database stuff. So have a good weekend.